data to data, and that is due to in ASTM distillation there is an absence of packings. So there is no any stages which are provided. We are not talking about reflux arrangement as well. So that's why it is not more elaborated curve which is obtained, and the accuracy of ASTM distillation is comparatively less. But still, for the case of final product, it is widely used, accepted testing method. Okay. Now this is what is an experimental setup which is there in our lab as well. So I have explained you different parts and how the separation will take place. So we are charging our crude oil here in a round bottom 3-neck flask, and the center neck of the round bottom flask is connected with a pack columns, and we will be heating the crude oil which is collected or charged at a round bottom flask, and there is a continuous vaporization condensation will be happening across the column length, and it will continues till till the temperature of vapor and column become equilibrium, and then the vapor will rise, and then the further condensation and reflux will be done in the column. So this is what is represented, and for that what is specific distillation rate, that is what I already told to you. Now typically when we are talking about uh, true boiling point distillation, we need to understand we are typically going to talk about only 5 cuts, because typically residue above 360 is not considered. It is typically ignored when we are talking about true boiling point distillation, and for gases also it is not widely done. So we will start our mixture itself with a naphtha to a residue. So when we are talking about a product distribution, there will be 5 products what we will be considering. Maybe a naphtha as an first product, kerosene, LGO, HGO, residue. So light gas oil, heavy gas oil, and residue which is coming out from the atmospheric distillation unit. So these are the 5 products which will be considered when we are talking about a true boiling point distillation. And typically their cut points what is followed, and again these all are coming from a Russian units. So degree Fahrenheit is converted for degree Celsius. That is what I have done. So typically naphtha is a little bit wider range from gases, maybe 30 degrees centigrade to 190 degrees centigrade, kerosene 190 to 250 degrees centigrade, LGO 250 to 320, HGO 320 to 360. That is what is a typical cuts which are considered for a true boiling point distillation. Now before moving forward, what is will be done in this particular experimental setup, the cuts are separated based on the boiling range. So the vapor temperatures are measured, and the condensation of the vapors will be done. The reflux arrangement will be adding a reflux again back to the column, and what will be done, volume collected will be measured against a temperature. So volume collected 0 to 10 percentage, 10 to 20, 20 to 30, 30 to 40. So volume percentage collected will be measured against a temperature, and that graph itself will be represented as an bar graph, where I am talking about that as an uh, bar chart where volume percentage is plotted against a temperature and the midpoint. So maybe what is a temperature required for 0 to 10% volume to be distilled, at what temperature? Same way 11 to 20, 21 to 30, like that. So it is a continuous bar graph which need to be plotted, and typically the midpoint of this bar chart will be connected, and that is what is represented as a midpoint curve, which is playing very much important role and concept in a petroleum refinery. Because when we wanted that data to be converted from one unit system to another unit system, we must know the midpoint curve which is need to be drawn. That is very much important. Okay, In this, if you have any queries or anything that need to be clarified or which you need me to answer, please ask your queries. If you have understood, please respond that way. If you have any queries or something which need again a discussion, clarification, please ask quickly. I am not able to see a chat box right now, so for that I need to log in again. Okay, you just put your responses quickly, because silence will not give me any understanding of where you are, what I'm talking about, and whether we are on the same platform. Only one student has responded. Lakshmi has responded. What about other students? Is it a difficult thing, or you are not in the class itself?
Understood, sir.
Okay. So shall we move forward?
Yes, sir.
Yes, sir.
Okay, thank you. Now I will talk about the conversion as well, ASTM to TBP conversion. But before that, I should talk about what exactly the ASTM is all about and how it need to be done, and then EFE, and then I will show you some important concept. Taking it forward, typically, though we are saying ASTM distillation, it is a standard procedure which need to be done, and it is again a distillation. So when we are talking about fixing a boiling ranges for a various component, okay, yes, I am going to talk about its significance, Mayur. In some time I will give you an idea what is the significance of this TBP data once we will be talking about TBP 50% to ASTM 50% and how they are correlated with one another. So I will talk about that significance as well. At least now you have understood the procedure. That is what is expected. So basically, if you just want me to give you overall significance, it is going to give you individual fraction wise how much quantity you are going to get collected. So if you just see my last slide, you will be able to see here what I have said. A midpoint curve is plotted. So a volume collected, maybe if I am saying for naphtha, I am able to get 50% of the crude oil to be distilled. So below 190 degrees centigrade itself, if I am getting 50% of the volume of crude oil collected, then what is the significance of that number? My conversion of crude oil to a petrol by a distillation itself will be much higher. 50% will be converted to naphtha fraction. Same way, if only 10% of the kerosene, so the boiling component between 190 to 250, next 10% of volume will be just collected, then around 10% of the sample will be a kerosene. So that is what is an overall significance of this particular test. Okay, overall significance is a volume is collected and we will be able to get an understanding of how much will be the quantity of different fractions that are available in a crude oil itself. Then further, if more of the heavier fractions are available, if we are going to get more of the HGO and above residue, then typically the further processing, the quantity and other things need to be considered, and then the load need to be calculated. So basically we will be going to end up with what we want. We want a lighter fraction to be more produced. Maybe if we want a gasoline to be more produced, we will be needing more of the treatment, because from this heavier fraction, we will be converting them again to a lighter fraction. So maybe a cracking feed will be more. In that case, we need to operate cracking unit with higher capacities. So that is what is a significance of this particular test from a nutshell, right now. Okay. Is it okay? Okay. So actually, this is just an overview I'm talking about. When we will talk about conversion and using the data, it will be important, and understanding that concept is very much important, because typically TBP will be done at both the sites, at extraction site of crude oil as well as in a refinery. Okay. Now moving forward, ASTM curve, and these are typically done for a product and not for a crude oil. So for a product, when I'm talking about, we are restricting ourselves to a liquid product, maybe gasoline, kerosene, diesel, and we need to finalize what is a boiling range in which that fraction is. So basically, when I am doing this analysis at LIT, they have collected a sample. So in and around there is an MIBC, and they have collected a sample, and then I am usually analyzing the samples. So when it comes for the heavier fraction analysis, maybe uh, uh, gasoline analysis, kerosene analysis, and characterization of that, whether it is blended with some higher fractions or it is added with some unwanted ingredients. Then for that, this is what is a test which plays very much important role. So I used to do this test. Just to give you an idea, when I'm talking about this particular test, you need to understand, uh, we received a sample from one petrol pump. So actually it is a sample taken by and government officers, and they have collected and sent that sample for testing to us. What used to happen? Uh, Basically, there is a blending of kerosene into a gasoline, and they wanted that to be characterized. So how much percentage is it blended, or it is only pure gasoline? So that need to be characterized. So for that particular case, I before doing that test itself, within 2-3 days, when my HOD has handed over that sample to me, there are few fellows which came to meet, and they claim that the sample which is collected is from their petrol pump, and they want the result to be manipulated. So they know what they did. They have done some malpractices, and they wanted that result to be. So what happened before that itself? So they meet with me. Then I said, I am not sure who will be going to get the sample itself. So I am not the correct person. You just go and talk to the concerned faculty who will be responsible for that analysis, because my HOD used to sign that letter. So they met with that person, and he has literally kicked them off. So he has returned the sample. So we have the, because what will happen, these all are